We're continuing our study of solving other types of equations, and today we're going to continue with solving radical equations. So we've already discussed rational equations and the work rate applications, and we'll look at radical equations today. Okay. When we talk about radical equations, a radical equation is an equation in which the variable occurs in a square root, cube root, or higher root. Meaning, let me show you some examples. If we look at this equation, x plus the square root of 26 minus 11x is equal to 4. This is considered to be a radical equation because I have this variable underneath this radical, so to speak. Here as well. This is the cube root of 4x squared minus 4x plus 1 minus the cube root of x. This as well is a radical equation. I have these variables underneath the radical. So we call these radical equations, and we're going to talk about today how to solve them. We're also going to talk about how to not only solve, but also how to check our work as well. Okay? So let's start off by let's start off by discussing the steps. Now, in solving a radical equation, there are 4 steps, and it seems like, oh, there are only 4 steps, this should be easy. Sometimes you will be repeating steps again, depending on the problem. For instance, our first step is to isolate the radical on one side of the equation. So we need the radical on a side by itself. If you have more than one radical, work to isolate just one at a time. So if you have 2 radicals, work to isolate one of them, okay? Raise each side of the equation to a power that is the same as the index of the radical so that the radical is eliminated. Well, what do we mean by index? Well, if I look at this expression, this says that's a 3. The cube root of x plus 2, the index is 3. This is our index. If it's a square root, you know that the index is not written, but it's 2. Now, we're going to be raising each side of the equation to a power that is the same as the index. Okay, so if I have an equation that's a cube root equation, or it has a cube root radical, I'm going to cube that side once I isolate it. Okay, so keep in mind, we're going to be using what we call the power property there, and I'll make reference to that and come back to that when we begin solving. Now, notice here that it says if the equation still contains a radical, repeat steps 1 and 2. That's saying that if we have more than one radical and we can only isolate one at a time, we work to isolate one and eliminate that radical, and then we work to isolate the remaining radical, and then we use the power property to eliminate it. So you can only eliminate, sometimes I should say, you can only eliminate one at a time. Then we solve the resulting equation, and then we check each proposed solution. Okay, in the original equation. And checking our work here is not optional, it's a must, because we will sometimes get extraneous solutions due to this power property that we're using. So these are the 4 steps that we're going to be using today, okay? So when I reference steps 1 and 2 and 3 and 4, you'll know what I'm talking about or what I'm referencing. So if you print out this slide, then you can have it. Or if we're using the Lyle book, you can look it up in your textbook, okay? Let's look at solving some equations now. And we'll start off with the first. We'll look at 2 of them, and I'll let you solve that 3rd one in class or during our study session, okay? So let's look at equation 1. It says solve x minus the square root of 4x plus 12 is equal to 0. So that's our equation. And it is a radical equation because we have a variable underneath this radical, so to speak. So let's look at it. First step says to isolate your radical. Okay, so isolate our radical expression. That's what we want to do first. Okay, on one side, so I want to move this to the opposite side. That way it's on the right-hand side of this equation, off to the right by itself. When we do this and we can bring down x, we get x is equal to the square root of 4x plus 12. Now we were lucky. In this problem we have only one radical expression. So therefore it's now isolated, and now I can go to step 2. Step 2 says, now use the power property. We are going to raise each side of the equation to a power that is equal to the index of the radical that we want to eliminate. So this is a square root we want to eliminate, so I'm going to square it. But remember, what I do to one side, I'm going to do to the other, so I want to square both sides. We are making use of that power property I discussed earlier. But because of this property, sometimes when we raise equations to powers, we create more solutions than there really are. So we will definitely need to check our solutions in the original equation because of this step. Okay, I just want to point that out. But now, what happens when we square x? We get x squared. And when we square a square root, we are left with 4x plus 12. And hopefully you'll see that this is a quadratic equation. Highest degree of this equation is 2, so it's a quadratic. So I want to get all terms on one side. Because when solving a quadratic, I either want to factor or I want to use quadratic formula. So I want all terms on one side. So let's bring down x squared. Then 4x and minus 12. And you know I can't add these because they are not like terms. This exponent is 2, this one is 1. The degree of this term is 2, the degree of this one is 1. So now I will factor. So my first terms will be x and x. Two numbers that will multiply to give me negative 12 but add to give me negative 4 are negative 6 and positive 2. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. And I set each factor that contains a variable equal to 0. That's that zero factor property we talked about. And solving each resulting equation, we'll get two proposed solutions. We get x is equal to 6, and we get x is equal to negative 2. Now, remember, when you are solving radical equations, you must check your proposed solutions. And I taught you one way on the calculator to check, and you also know how to check by substituting into the original equation. Let's do that at this time. So I want to be sure that both are true solutions. Well, let's see. I'm going to check this by substituting into the original equation. And if I get a true statement, then I can accept the number as a solution. If I get a false statement, then I reject it and treat it as an extraneous solution. So let's start with 6. I'm going to substitute in 6 everywhere that I see x. So 6 minus the square root of 4 times 6 plus 12. Is that 0? Well, let's see. 6 minus 6 times 4 is 24. 24 plus 12 is 36. And the square root of 36 is 6, so 6 minus 6 is 0. That checks out. X equals 6 is acceptable. Let's try negative 2. So I'm going to now substitute negative 2 into the original equation. So negative 2 minus the square root of 4 times negative 2 plus 12. Well, what happens here? Negative 2 minus the square root of, let's see, negative 8 plus 12 is 4, and the square root of 4 is 2. So negative 2 minus 2 is not 0. Negative 4 is not equal to 0. False statement. So I must reject this extraneous solution. It is not a solution. Okay? So I only accept one answer, and that is x equals 6. Okay? So the only solution to this radical equation is 6. And we see that because negative 2, when substituted back into the original equation, gave me a false statement. So we reject it, and it is not accepted. It's a false solution. Okay? And remember, because we are applying this power property, we are sometimes creating more solutions than there are for our original equation, so we must check our answer. Okay? Let's look at another. One more. And then I have several more for you to practice, and there are also several that you can look at on my math lab to get some additional help. We'll look at number 2. Let's look at the second one. The second equation we're going to solve is the cube root of 4x squared minus 4x plus 1 minus the cube root of x is equal to 0. This will be our second equation. Now, our first step is to isolate one of the radicals. I actually have 2 radicals, and it's up to you to determine which one to isolate. I can isolate the second or the first. There's no wrong place to begin. If you begin by isolating the first, that's correct, or the second. But we work to isolate one. So I'm going to move this. Since it does have a negative in front of it, I'll just go ahead and move it to the opposite side. So now I have the cube root of 4x squared minus 4x plus 1 is equal to the cube root of x. Now, I want to apply the power property. I want to raise each side of this equation. I'm just going to rewrite it. Raise each side to a power equal to 3. So I'm going to I'll cube both sides. When we cube a cube root, we eliminate the radical, leaving us with 4x squared minus 4x plus 1, and here x. This is a quadratic equation. The highest power is 2. So we want to get all terms on one side. So I'm going to subtract x from both sides, leaving us with 4x squared minus 5x plus 1 is equal to 0. Okay? Now, we have a quadratic equation. All of our terms are on one side. So we can solve this equation by factoring, completing the square, or quadratic formula. Those are our methods that we discussed in the previous section. So let's go ahead and factor. I'm going to factor this by trial and error. And I want to find, and remember, trial and error is just as the name suggests. We try something. If it doesn't work, we try something else. So I want to try 4x and x as my first terms, because remember, these two terms must multiply to 4x squared. So our first terms must multiply to give us our first term here. And now I want to find a way to get positive 1. And I'm looking at this middle coefficient, knowing that my sum should be negative. And if I want to multiply two numbers and get a positive 1 and add eventually and get a negative 5, both signs need to be negative. So I'm going to use negative 1 and negative 1. So 4x minus 1 times x minus 1. If I use FOIL to multiply this out using FOIL, I'll get 4x squared minus 5x plus 1. Or I can check my inner terms. Negative x times negative 1 is negative x. My outer terms product will be negative 4x. And negative 4x plus negative x is my middle, negative 5x. So my factors are correct. Now I set each factor that contains a variable, which is both, equal to 0, and I solve. This is the 0 factor property we worked on earlier. So when I add 1 to both sides, we will get 1/4. And here when I add 1 to both sides, we'll have x equals 1. Now, don't forget, I'm not going to check these with you, but you must check your work. You can check it in your graphing calculator as I showed you before, or you can substitute, as in the previous example, 1/4 first into our original equation and see if the left side equals 0. The left side equals the right, and it will. Then do the same with 1. Substitute 1, our proposed solution x equals 1, into the original equation, and this left side, when we subtract these two numbers, should be 0. You must check your work. To save a little time, I've already checked, and I know that 1/4 and 1 are both solutions. I hope this helps you with your homework for this particular section.